I help a key group of Notion stakeholders learn Notion's most advanced features. They explore my resources in Notion A to Z, and then we convene for a series of live lessons. So, through this Notion Stakeholder Series of videos and tutorials, I'm making those lessons available to you. And members of Notion A to Z will access all of the interactive features, including the working demos and the practical exercise. And if you're not yet a part of Notion A to Z, I encourage you to join us so that you can master and make the most of Notion.
So, what is a formula? Well, within a formula property, you write sort of a mini computer program, and it has kind of its own special language for doing that. So, for each formula property, you compose the formula just once. And then when the database loads, it's going to execute that formula for each item of the database. And so for each item of the database, that formula is going to return just a single value, which is important to remember. And you'll see why. And typically, formulas reference other properties of the database. And that's why each execution of the formula or each item of the database, the formula can return a different value because those properties that are referenced by the formula can have different values for each item of the database. So, as a quick demo here, we're going to be looking at online orders as sort of a demo database. We'll be seeing how to use formulas in a variety of ways for this sort of entity that you would save and work with in Notion. So, within this preliminary demo, we have for each order a subtotal and then a tax. And then what our total property does is it adds the subtotal and tax to calculate the total for each order. So this formula property here references these other two properties, adds them together to calculate the total. So I'm going to be giving you some little exercises to complete as we learn each new concept. And I'll have you do that in a page that we'll call your sandbox. So I'll walk you through quickly the creation of your sandbox. We're going to just create a new page. And for that page, choose the table layout to make it a database. And you can call the database your sandbox or, your name as in Williams sandbox. And then for the three default items, let's call them item A, item B, and item C. And as a general rule of thumb, I always apply a sorting rule to every database and every view of every database in Notion that's going to prevent sort of some unpredictable behavior. So let's just sort by that default name property, the title, and you can leave that default multi-select property. We'll convert it to a formula here shortly, but here's kind of what you should end up with for your sandbox. Alrighty, so why use formulas? Well, I have kind of five overarching categories for why you would use a formula. The first one is to perform calculations. So formulas can perform mathematical calculations on numbers and dates. And that's exactly what we saw in our first demo. That total property added the subtotal and the tax to calculate the total. The second high level category for using formulas is conditions. So, what a formula can do is it can test other properties to see if they meet specified conditions. And if they do meet certain conditions, they can perform certain actions. So, one example of that would be that tax rate property that we saw in our demos database. That's actually a conditional formula. So for the state property, if we choose North Carolina, that formula is going to return a 4.75% tax rate. If we choose New York, it's going to return a 4% tax rate. So if we change New York to NC quickly here, the value of that formula is going to change to 4.75%. So we can return a value based on the conditions of other properties, which is a really important capability of formulas, one that you'll use often and that users use often. So the third high level category for using formulas is extraction. So you can take other properties and extract elements of those other properties. One example of that is in our orders database. If we have a full name property, we can use formulas to extract the first name and extract the last name for each customer. And this is going to be useful. You may want to sort your database by last name. And if you want to send a mass email, for example, and you want to address each customer by the customer's first name, you can use that first name property because we've extracted that first name from the full name. Then we can also use formulas for formatting. So Notion's pretty limited in its options for formatting numbers and especially dates. And that's going to be especially true also for roll up properties. But with formulas, you can format numbers and dates in virtually any way that you may want to. So for our orders database, we have an order date property, and we use one of the few options that Notion offers us for formatting. But if we wanted to have this hip little series of 2-digit combinations, one for the month, the day, and the year separated by a period, this format is not offered by Notion, but we can use a formula to generate it. And you'll see how we can take this and apply it for a variety of uses that we may want to make our databases more visually appealing. So, again, that fourth category for using formulas is reformatting other values. And then the last one is concatenation. So concatenation is kind of the opposite of extraction, and that is taking multiple other properties and merging them together. So in the case of our orders database, what we can do is we can generate kind of an order summary by combining other properties of the order. We can bring them all together here within this nice order summary that we've made possible with formulas. And you can see here that this uses that nice date format that we created. So we'll look into how we do all of this as we explore formulas, but let's take a look at the formula window. So when you go to edit a formula, you're going to be working within the formula window. After creating a formula property, you can go into that properties menu and choose to edit the formula, or you can just click into any cell within that formula property. That's going to prompt the formula window. And the formula window has three primary sections. At the top is where you compose the formula. Remember, when you're writing a formula, you're using a special language to compose kind of a mini computer program that executes for each item of the database. So this is where you write the formula. Over on the left side is a menu, a list of items that are sort of the ingredients that you can use within your formula. And as you'll see, there's two kind of categories of ingredients. One is the input values that you supply within your formula, and that's going to include the other properties of the database. So you'll see those other properties listed within this menu, and you can click to add them to the formula. And then the other high level category of ingredient that you'll use within your formulas is the actions to perform on those input values. And those often take the form of functions and operators. So if you hover over any of these ingredients within this left side menu here, in the right side of the formula window, you'll see some helpful information about the highlighted ingredients. So it'll be a brief description. It'll offer the syntax for how to use the ingredient, and then one or more examples. And we'll dive into what all of that means. So let's take a quick look at the formula window in action. Remember, within our orders database, we're calculating the total by adding the tax amount. So if we click into a cell within that total property, we can see that we have the formula window here. And up here is the formula that calculates the total, and we'll be familiar with exactly how that's done here in no time. Over here on the left side is that menu of ingredients that we can add to our formula. And you can see as I hover over these various items, the information within the right side changes. So we have the other properties of the database, and then we have all of the actions that we can perform on those values. So let's quickly practice within our sandbox, working within the formula window. Go ahead and take that multi-select property, the default multi-select property of your sandbox database, and convert it to a formula property. And you can just rename it to formula. And after you've done that, click into any cell to prompt the formula window, and then just kind of wander around there a little bit. Notice how you can type within the top. You can scroll along the items on the left, and notice how when you highlight the items on the left, the information on the right changes. So we'll be familiar with all that here shortly. Now let's dive more deeply into those ingredients that I briefly overviewed already. Like I mentioned, you're going to be using kind of two high level categories of ingredients within formulas. You have the input values, and then you have the actions to perform on those values. So when we look at our subtotal tax and total properties, the total property is that formula that we're focused on. So its inputs are the subtotal and the tax. We have those two input values. And then the action that we want to perform on those values is addition. So we have our subtotal as an input, our tax as an input, and then our action is to add. So let's explore input values and actions, beginning with the input values. There's three primary methods of supplying input values to a formula. We have literal values, constants, and then property references. And before we dive into those, I want to briefly talk about data types. Data types are an important concept when you're working with databases, and particularly with formulas. So every value within a property of a database, including formulas, but also every other property type, it's going to be one of four data types. So a value within a Notion database property can be a number, it can be a string, which is text, it can be a date, or it can be a Boolean value, which is true or false. Every value within every property of a Notion database is one of these four data types. And part of the reason it's so important to stay mindful of data types is because when you're working with formulas, remember we have input values and we have actions to perform on those values. And so only certain data types work with certain actions. For example, you can't divide a number by a text string, right? You can only divide a number by another number. And as you'll see, a lot of times formulas will find the amount of time between two dates. So obviously, you can't find the amount of time between a text string and a date, or a number and a date. You need to have two dates. And whenever you try to supply incompatible data types to a Notion formula, you're going to get what's called a type mismatch error. And inevitably, you're going to see this. It's going to be the error you see most often. In my own work with formulas, I continue to experience it. And so, you go through a process of sort of debugging, reviewing your formula to determine where the error is. But most often, it's going to be due to a type mismatch. So if we click into our formula property here and we add a text string, you always surround the text with double quotes. That's going to distinguish it as a text string. So if we try to add the word to, the text string to the number two, you can see here that we get a type mismatch error at the bottom, and it's telling us that 2 is not a text, meaning this number it's looking for this number 2 to also be a text string. But if we change this string 2 to a number 2, then we're able to submit our formula successfully because we have compatible data types. They're both numbers. So once you have a adequate formula, you can either click done or use the keyboard shortcut command return on Mac. So let's take a look at another type mismatch error within your sandbox. Click into your formula property, clear what's already there, and then type any number. And let's use the forward slash now for division. And let's try to divide that number by a text string. So just enter your favorite animal within quotation marks, for example, and notice that we get a type mismatch error. Now change that text string to a true number and submit. We're able to do so, and you can see that our formula is successfully returning a value for us. In this case, it's a number. So when working with formulas, the inputs that you supply your formulas, they're all going to be of a certain data type, one of those 4 data types that we reviewed: number, text string, date, or Boolean, which is true or false. And then that single value, remember, every formula returns just a single value for each item of the database. No matter how complex the formula, you're always going to get a single returned value. That single returned value is also going to be one of those 4 data types. So if you go to reuse that value or you use it within a calculation, you're going to want to know what data type it is so that you know what capabilities are offered. So those are data types. We'll be referencing them often. Let's take a look at those 3 different methods of supplying input values. The first one is literal values. That's when you just directly type the value into your formula. And what that means is because you're typing the value into your formula directly rather than referencing it from somewhere else, that value is going to be the same for every item of the database. So when we were entering, a 2, for example, within those demos, we got the same value returned for each item in the database because that 2 was used for each execution of the formula. Now, remember, other times, as we'll see here in a second, formulas will reference other properties of the database. And so those other properties can be different for each execution of the formula. But when you supply literal values, when you type the value directly into the formula, every iteration of the formula is going to use the same value. So let's take a look at 2 quick examples here. If we just type the number 2 into our formula and submit, then we get a 2 for each iteration of the formula because it's a literal value. Items A, B, and C all use a 2. If we add that 2 to 3, that 3 is a literal value as well, along with the 2. So if we submit, we get 5. We get the same value for each iteration of the formula because we're supplying our values literally. We can do the same thing with text values. If we just write our first name and submit, then our formula returns our first name for each item of the database because when we provide literal values, every execution of the formula is going to use the same value. So let's give that a go in your little sandbox within that formula property. Just type the number 2 and submit it, and you get the number 2 for each item of the database. Now let's try a text string. Type your first name. Use quotation marks because double quotes are used to indicate text strings within formulas and submit. And we get the same returned value for each iteration of the formula. So you'll use literal values pretty often. You'll probably use them often with property references, which you will not necessarily use that often are constants, but it's important for you to be familiar with constants. Notion provides two kind of preset values that you can generate with two simple keywords. One is pi, and the other is a lowercase e, which is the base of the natural logarithm. I never use these. Most users absolutely never use these, but it's just good to be familiar with them in case you come across them. So if we just enter pi into a formula and submit, then we get the value of pi. And then e's the exact same. If we just type e, then Notion is going to return the base of the natural logarithm. So give that a quick try within your formula property. Type pi, submit. There you go. Then replace it with an e, submit. There you go. That might be the only time you ever do that. So literal values are important. Constants you'll use infrequently, but they're good to know. Property references is the third way that we provide our input values to formulas, and they're really the most important. Like I said, you'll use property references often in combination with literal values. So remember, literal values are entered directly into the formula, and every execution of the formula for each item of the database is going to use the same value. Now, with property references, you're referencing other properties of the database. So each item of the database can have a different value for that reference property. And that's why the formula can return a different value for each item of the database, because that formula is using the value for each item of the database, which can be different. So the way that you reference another property is you type the prop keyword, and then within parentheses, you provide the name of the property that you want to reference. And you provide it as a text string technically. So that means that we're using double quotes. And within your formula window, you'll see a list of the other properties, and you can just click one to add it to your formula. But when working with property references and the other ingredients of your formulas, as you're learning them, I encourage you to type them from scratch. That's going to really help you to become familiar with how they work and how they're structured. So let's take a look at a very simple property reference. Within this demo database, I have a priority property. It's just a number. And for each item of the database, I have a different number, right? Now, remember, when we were entering our literal values, if we just typed the number 3 and submitted, we get a 3 for each execution of the formula. Every item of the database is going to use the same value because we entered it literally. Now, if we instead reference another property, in this case, if we reference the priority property, then we're going to get a different returned value for each item of the database. So we type that prop keyword. And then in parentheses, we supply the name of the property we want to reference. And we put it in double quotes because it's a text string. So I'm going to type priority, close the quotes, close the parentheses, and submit. And now you can see that this formula is just reflecting the priority property. We've referenced the priority property. It's our only input for this formula. So it's just returning that priority property because we have a simple property reference. So let's give that a whirl in your sandbox. What we'll do here, click into your formula property, clear what's already there, and let's just reference the name property, the title property of your database. So type the prop keyword, open up your parenthesis, and then in double quotes, type name because it's the name of the title property in our sandbox database. Then close the parentheses and submit. And you can see that our formula is just reflecting each unique name for the corresponding item of the database. So we've just got a simple little formula with one input, and that input is a property reference. In this case, we're referencing the name property. So, quick recap, we provide our input values for our formulas in three ways. We can type them literally. When we do that, every execution of the formula is going to use the same value. We have constants, which are just those two preset keywords that Notion makes available that we almost never use. And then most importantly, we have property references, which reference other properties of the database, which can be different for each item of the database. And that's what allows our formulas to return a different value for each item of the database. So those are input values. And that's the first kind of high level category of ingredient that we provide to our formulas. And then the second ingredient is the actions that we want to perform on those values. And we have two methods of specifying the actions that we want to perform on those values. We have operators and we have functions. So let's start with operators. Operators are simple, kind of one or two characters that you place between your input values to specify the actions that you want to perform on those values. And they fall into three categories. We have arithmetic operators, comparison operators, and then we have a concatenation operator. And if you've been working through Notion A to Z, you may have seen that we have an index of all the operators that Notion offers in a way that's categorized with an explanation. You can take a quick look at that. Here, you can see that they're grouped by those categories that I just named. So, arithmetic operators, don't overthink it. You're familiar with arithmetic operators. You've used them in the past. We've already used them today. That's just, the plus sign, the forward slash for division. The dash is going to indicate subtraction, and then the asterisk will be multiplication. So, as a quick demo here, revisiting our orders database, we have our total that's calculated by adding our subtotal and tax. So, hopefully, this is beginning to make a little bit more sense to you now. We can see that we're using property references here, right, with our keywords to retrieve the values of those other properties. We're referencing our subtotal property and we're referencing our tax property. And we place a plus sign between them. That's the addition operator in this case to tell the formula that we want to add them. So let's quickly practice an arithmetic operator within your sandbox. What we can do is let's just use some literal values. Type the number 4, and then let's use a forward slash for division. Let's divide that 4 by 2. When we submit, we get a 2 for each item of the database because we supplied the formula literal values. And between those literal values, we added the division operator. So we were dividing those numbers. Now remember, we're using two literal numbers here. If we were to provide a text string, we're going to get one of those type mismatches. So that's arithmetic operators. And again, you can reference all of them within that link here. And I'm going to make this page available to you with all of these contents. So you can duplicate it for reference, and you'll also be able to inspect all of these demo databases to see exactly how they're configured. So the next type of operator is going to be the comparison operator. And what comparison operators do is they test one value against another value and return a Boolean value, which you'll recall is true or false. And when a formula returns a Boolean value in Notion, it's going to be visualized as a checkbox by default. So if it's true, it'll be a checked checkbox. If it's false, it'll be an unchecked checkbox. And typically, when you're making these comparisons, you're going to be comparing values of the same data type. So you compare numbers to numbers and dates to dates and so forth. So, as with arithmetic operators, you're familiar with comparison operators. We have greater than, less than or equal to, and so forth. When you want to compare values, when you want to see if they're equal, you use two equal signs paired together. If you want to test if they're unequal, you use an exclamation point followed by an equal sign. And remember, you have that index to reference as you become familiar with all of these different types of operators. So let's look at a quick example here. If we want to see is 2 equal to 3, we'll use those two equal signs and submit. And you can see that we get an unchecked checkbox here. If we could change this to is 2 less than 3 and submit, and now all of our boxes are checked and we get the same value for each execution of the formula because we're using literal values. So give it a quick go in your sandbox, click within your formula property, and let's see, is 1 less than 2? 1 is less than 2. We have our checked check boxes. Now let's see, is 1 equal to 2? Change that less than to 2 equal sign, submit, and it's not. So we get all unchecked check boxes. So that's comparison operators, which always return a true or false after comparing values. And then lastly, we have the concatenation operator. This is straightforward. So we saw that the plus sign, when you place it between numbers, it's going to add them together naturally, which you're accustomed to. But if you place the plus sign between two text strings, it's going to merge them together. And merging text strings is also known as concatenation. So you can see over in our order summary, which we've already seen, you don't need to be concerned so much with all of the input values, but each of our inputs is separated by a plus sign. So these plus signs, they're not adding numbers together. Instead, they're just joining text strings or merging them, or the technical term is concatenation. So let's do a simpler practice within your formula property. Type your first name, add a plus sign, type a space between quotation marks, add another plus sign, and then type your last name in double quotes. And you can see after we submit that what the formula has done is merged your first name, a space, and a last name. So those are operators. We have arithmetic operators, which are, the plus and minus signs that you're familiar with for performing actions on numbers. Comparison operators, such as less than and less than or equal to, return a Boolean value after comparing values. And then our concatenation operator is just the plus sign placed between text strings, and it merges them together or concatenates them. So operators are just one or two characters that you place between input values. The other way that we specify actions within our formulas, the actions that we want to perform on our input values, is functions. And functions are kind of like packaged actions to perform on the inputs. And there are functions that simply replace operators. There's a function for adding, there's a function for, dividing, and for all of the comparisons. For every operator, there's an equivalent function that performs that same actions. But other functions perform more advanced operations, such as converting one data type to another and performing complicated calculations and conditional tests. So, along with all of those ingredients that you can supply to your formula within that menu on the left side of your formula window, you're going to see all of the functions available. And that's where that right side informational area is really going to be most helpful. Is when you hover over a function, you're going to see exactly what the function does and the requirements for that function, exactly how to use it. Although that information is a little bit limited. So I have this Notion formula cheat sheet that I'm told is referenced often by the Notion team itself, and it's just gonna provide a good amount more information than that little right side pane within the formula window. You'll find this to be a little bit more intuitive and a little bit more comprehensive as you're working with formulas. So I've linked to that here, and you can reference it as you're working with formulas. And this is not the kind of thing where once you've learned it, you never need to reference these other resources. Remember, you're kind of composing a mini computer program with a formula with a whole special language. And so you'll always be referencing these other sources as you're working with formulas. So you never kind of memorize all of this information. So let's take a quick look at a demo function before seeing exactly how they're composed. Remember, for every operator there's an equivalent function, and that includes obviously addition. So if we want to add 2 and 3 as we did previously, we can do that with the plus sign, the addition operator. But with a function, we can use the keyword add, supply it the input values 2 and 3, and it performs the exact same action. So we'll see exactly how that works in the anatomy of a function. So as you just kind of saw, each function begins with a keyword, and that keyword is typically going to describe the action that it performs. We just saw how add is the keyword for the addition function, and obviously it's a clear indicator of the action that it performs. And then within parentheses, you supply the function the input values that you want it to operate on. So obviously, you can supply those input values in all of the ways that we discussed previously. They can be literal values, they can be property references. And in the case of functions, those input values are known as the function's arguments. So you have the keyword, you have parentheses, and within the parentheses, are the formula's arguments, which are the values on which you want the action to be performed. So each function has specific requirements for the arguments that you can supply it. Sometimes that means it only accepts a certain number of arguments, and most importantly, it means that those arguments need to be a certain data type typically. So this is the type of information that you see over within that right side of the formula window. When you hover over a formula, it's going to tell you the information that you didn't need to know about providing the arguments to a formula or its input values. So you separate its arguments with a comma. So let's take a look again at that simple add example. Remember, what we did is we typed the add keyword. This is the add function. And you can see over here on the right, as we type it, it's going to filter that list of items over here on the left. So we can highlight add. And when we do that, you can see that we have a description, we have the syntax, and then we have an example or multiple examples. So when you see the syntax for a formula, you're going to see examples with both the operator version as well as the function version. The operator version, the addition operator, that's obviously straightforward. But when we're working with functions, this information is going to be more helpful. So you can see in this example here, when we're looking at the syntax for the add function, it says add, and then we see number. That means we need to supply as arguments 2 numbers to the add function. Now, this add function also functions as a concatenation function, so we can supply it to text strings as well, and it's going to merge them together. But we can't mix numbers and text. We either need 2 numbers or 2 text strings. So if we type our add keyword and then open parenthesis, we can provide it a 2 and a 3 separated by a comma and submit. And so we've used the add function to add 2 and 3. And then because add could also accept 2 text strings, I can add my first name And I'm going to go ahead and include the space with that first argument and then my last name. And you can see that it has concatenated those two text strings. So let's give it a quick practice in your sandbox. Let's use that add function. Type the keyword add, open your parentheses, and then just give it any two numbers separated by a comma. And you'll see that it adds them together. And obviously, we're supplying those input values as literal values. So we're going to get the same returned value for each item of the database. So that's the anatomy of a function. We've got our keyword, and then we've got parentheses. Within those parentheses, we supply the arguments for the function. Let's take a look at our different types of functions. And again, you never memorize all the functions and all of their requirements. You'll always reference different sources as you're working with functions, sometimes just in that formula window, and then in other cases in resources such as that cheat sheet. So I kind of categorize functions in four ways. And typically that's by the data types that it accepts as its arguments or the data type that it returns. So we have numeric functions, text functions, date and time functions, and then logic functions. So numeric functions, we've already seen add, for example, it's going to accept numbers and typically return a number as well. Numeric functions perform mathematical calculations on numeric values and typically return a number. We saw add in a later workshop. We're going to look at the most common and the most useful functions within each of these categories. And when we do that, we'll be looking at round, max, and min within the number category if you get curious and want to go ahead and explore those beforehand. But numeric functions are going to accept numbers and return a number most often. And then text functions typically manipulate text strings. So we saw how add can merge two text strings when you supply them as the add function's arguments. And then the concat function actually does the exact same thing, but it accepts more than two arguments. That's the difference there. Remember when we looked at add and we saw that add can accept two text strings? This is limited to two text strings. So this is going to concatenate those two text strings. But if we use concat, we get text followed by three dots and ellipsis. And what that means is it takes basically an unlimited number of arguments, but they do all need to be text. So you can see how this syntax area is helpful here. It's telling us what the data types that it accepts, as well as the number of those arguments that it accepts. In this case, it accepts an unlimited number. So now we can type within quotes, William, comma, space, comma, nut, and submit. And we've used the concat function to merge those three text strings and return my full name. So let's try that in your own formula property. Type the concat keyword, and then within parentheses, separate your first name and then a space, and then your last name, all in their own sets of quotation marks. Close the parentheses and submit. So that's a text function, concat. And then date and time functions you'll use often. They're very useful and also kind of challenging, probably the most challenging of all of these categories. But date and time functions, they'll either accept dates as their input values or they'll return a date as its returned value. Now, unlike other data types, you can't literally enter a date into a Notion formula, which is kind of a subject of frustration. You can't just type, January 14th, 1987. There's only three ways that you can provide a date to a formula. You can reference a date property, which is the most common way. Remember, a property reference is one of our three methods of supplying an input value. So if you have a date property, you can reference that date property, and the formula is going to use the value of that date property for each item of the database. That's the most common way to use a date in a formula. We also have the now function, which we'll be referencing often. And the now function just accepts no arguments. What it does is when the database is loaded, it just returns the current date and time. So you can imagine that would be helpful if you wanted to find the amount of time between a previous date and now, or the amount of time between now and an upcoming date, such as, the amount of time remaining before a deadline. And then the third way to provide a date to a formula is with the from timestamp function. You'll probably use that pretty infrequently, but what this does briefly is it takes a Unix timestamp basically, which is just an integer, and it's the number of milliseconds since midnight UTC January 1st, 1970. So you could just enter, an integer there, and what that's going to do is it's going to interpret that integer as the number of milliseconds since that date and then convert it to an actual date. So there's some advanced reasons you would want to use that, but at this point you definitely don't need to be concerned with it. So two common date and time functions that we'll be exploring more in a later lesson are the date between and the date add functions. So what date between does is it finds the amount of time between two dates. And as I mentioned, you'll typically do that by finding the amount of time between now and another date. And that other date could be in the past or it could be in the future. So another example there would be if you have a database of people and you have a birthday property, a date property where you enter that person's birthday, then by calculating the amount of time between the birthday and now, you determine how old that person is. And then the date add function allows you to add time to any date. So let's look at an example of that here. The date add function accepts three arguments. The first one is the initial date, the starting date, the date to which you want to add a value. The second argument for date add is going to be the quantity that you want to add. And then the third argument of the date add function is going to be the unit of that quantity. So if we type our date add keyword, open the parenthesis. Actually, before we open the parenthesis, let's look at what this right side area tells us about date add. You can see here that within syntax, it has date add and it says date, number, text. And then within these examples, we can see what exactly that means. So we have the date, which needs to be a value, a true date, a value of the date type, the amount being the amount that we want to add to it. And then the third argument is going to be a text string, but that text string is the unit for that amount. And that's going to be within quotation marks, since we're supplying it as a text string. It's going to be the unit, all lowercase and in plural form, even if the amount is just one. So back up to where we're composing our formula. We type our date add keyword, we open our parenthesis, and remember the first argument of date add is the date to which we want to add a value to, the starting date. In this case, we want to reference the date property. So I'm going to type our prop keyword, and then in parentheses, I'm going to supply the name of the property as a text string. So we have our first argument supplied to the date add function. The second argument is going to be the quantity that we want to add to it. So in this case, just for arbitrary reason, for demo's sake, we're just going to add 1 month to it. So I'm going to enter 1, and then we want to tell the formula what that 1 represents. In this case, it's going to be months. So within quotation marks, I'm going to type months, plural, all lowercase, and then close our parenthesis and submit. And you can see that we have within this formula property for each item of the database 1 month later than the date value. So let's do that in your sandbox. Add a date property really quick, and you can just call it date. And then for each item of the database, add a date, make each one unique. And then in the formula property, let's add 5 days to each of those dates. So what you'll do is you'll type date add. And notice how date add is all one word, but when we get to the add part of it, we use a as an uppercase. This is called camel case because it creates kind of a hump at each new word. So the first argument is going to be our date property. So we want to reference date. So type the prop keyword, open your parenthesis, and type date within quotation marks. Then close the property reference, add a comma. The second value is going to be 5 because we want to add 5 days, right? Comma. And then we're adding days. That 5 represents 5 days. So all lowercase and plural, supply days as a text string in quotation marks, and then close the date add property and submit. You've got 5 days later than each date value. So those are date and time functions. And again, we'll be exploring the most common ones, the most useful ones in later sessions. So the last category of functions is logic functions. And so what logic functions do is they compare their arguments. And we saw how, comparison operators are used to return a true or false. That's what logic functions do. But really, the most important logic function, and one that you'll use very often, is the if function. And the reason that the if function is so useful is because it allows you to specify a operation to perform based on the result of a comparison. So we saw how comparison operators return true or false. But the reason you would want to do that is because when you make those comparisons, you can say, with the if function, you can say, well, if it's true, I want to do this. If it's false, I want to do this. That's what if allows us to do. And we'll be diving deeper into that later. But let's look at some simpler logic functions here for now. So, one being the larger than or equal to. So this is just the equivalent of the greater than or equal to here. So let's use that operator is 3 greater than or equal to 2. That's using the operator. Of course, we get all check marks there. But what we can do is instead of using that operator, we can use larger equal function and then provide those same values as its 2 arguments and submit, and it's going to perform the exact same action and offer the exact same results. And of course, the results the same for every item of the database because we're using literal inputs. So let's try that larger than or equal to function within your sandbox. Type larger and then EQ with that capital E because we're using camel case here, and then give it any 2 values. So I'll do a 5 and a 6 this time, close it out, and submit. And we get all unchecked checkboxes because 5 is not larger than or equal to 6. So that is a simple logic function that'll really be important when we dive deeper into if in a later session. So that's a good hearty introduction to formulas. Of course, it's way more to digest than you can kind of capture in your head in this one session. So you'll have this page available to you. You'll have this recording available to you. As a very quick recap, we have our various reasons for why you would want to use formulas, perform mathematical calculations, to test for conditions, to extract values from text strings, to reformat other properties, and then to merge text strings. You use the formula window to compose your formula and access helpful information about the various ingredients that you can supply to it. And then most importantly, you're working with 2 different types of ingredients in your formulas. You've got the input values, you got the actions to perform on those values. Those input values you can provide literally. You can use those constants that Notion offers that you'll almost never use. And then most importantly, you can reference other properties so that each input value is different for each item of the database as the formula executes. Then you have the actions you want to perform on those values, which you can supply as operators, which are those simple 1 or 2 characters, or we've got functions, which are those pre-packaged actions that accept arguments, and you can reference those within the formula window or with a little bit more detail, that Notion formula cheat sheet. Like I said, you never learn everything there is to know about formulas and functions and so forth. You'll always be referencing these other resources, but the more you work with them, the more you'll understand them and the more you will retain in your head. So I have assembled a practical exercise to help you practice these concepts. I'm going to have you create an expenses database. And what you'll do is you'll create all of these properties within that expenses database. And then I've also given you some guidance for the contents to enter into those properties. So some of those will not be formulas. You'll be providing numbers, dates, text, and so forth. But then you'll also be using formulas to automatically populate values in a way that'll really help you to understand how these formulas are so powerful. And if you get caught anywhere, you want to validate the outcome of your exercise, I've got the final output down here within this result toggle. So there's your introduction to formulas. We'll have opportunities to answer questions in the future. And like I said, you'll have this page available to duplicate with all of its functional demo databases, as well as the recording of this Zoom session.